Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing exponential functions, specifically from graphs, and we will do it in 5 minutes or less. So we have an exponential function graphed here, and we need to find the function that is best represented by this graph. But how can we do that if all we are given is part of a graph here, we don't have any points? Well, let's remember what our goal is. Our goal is to get something that looks like this. Y equals AB to the x power. And we know some things about the A, and we know some things about the B that are going to help us here. So the A, right, is going to be our principal if we are dealing with compound interest. We can also view it as our starting point. So that's our constant. How much are we starting with? And then we're going to be typically multiplying it by this B, which is some type of rate or rate of change. And it's either going to be a growth rate or it's going to be a decay rate, depending on whether it's increasing or decreasing. And then this Y, this X, is usually some type of time factor. How many months, how many years, if it's growing exponentially or decaying exponentially. So this starting point, another way to think about this is what's going to help us most, and that's going to be our y-intercept. So we can view this A in multiple ways, depending on the context of the problem, but the most helpful one is going to be this y-intercept, because we can ask the question, well, if x equals 0, right, since this x, this time, would equal 0, that means it's the starting point. And we're not necessarily multiplying it exponentially, which is the starting point. So then what does y equal? And that's our starting point, that y-intercept. So we see that right here. What we need is a nice clear y-intercept. When x equals 0, y equals 2. Okay, so that's our starting point. So now we can start filling it in like this. Y equals, if my A equals 2 times B to the x power. Well, once we have that, we really have the hardest part done, because now we simply need to find a pair of coordinates here. So let's find some that are going to be an integer. So I'm seeing 2 that we could use right here. So this is a 1, so we could use 1, 4, and then we could also use this negative 1, 1. So let's do both, but let's start with this 1, 4. If we want to find that b, because that's the only thing we're really missing, well, we have an x and a y, which means we would only have one variable. We can solve for that variable. So let's say our y, 4, equals 2 times b, and then that x is going to be 1. Well, what happens when we get anything times 1? We need to know our exponential rules. Anything times 1 is just going to be itself. So really, 4 equals 2b. We're going to divide both sides by 2, and look what you have. B equaling 2. All right, so if that's the case, we would write it like this. Y equals 2 times, parentheses, 2 to the x. That would be something that would represent that. Let's see if we get the same thing if we use that other set. All right, so y equals 2 times b to the x. We're going to substitute in our y as 1. And then we're going to substitute in our x as negative 1. All right, so once again, we need to know the rules for exponents here. And when we have a negative, that just simply means it's going to go into the denominator. So 2 over b, because that negative makes it go into the denominator, to the 1th power. Still, same thing. To the 1th power doesn't do us anything, so that's 2 over b. We need to multiply both sides by b to get it out of the denominator. So b equals 2. Same thing. And so that is how we write exponential functions from graphs.